All right, welcome back. Let's do another example. This is more or less the example that is closest to the kinds of questions that you will see on an assessment. All right, so this is from your book. According to the manufacturer of peanut M&Ms, so really good M&Ms, in a single bag of M&Ms, there should be 12% brown, 15% yellow, 12% red, 23% blue, and 23% orange, as well as 15% green colored M&Ms. Notice that that's a claim distribution. So this happens a lot with manufacturing. We know what the results should be. So claim distribution. Now you're going to buy a bag of M&Ms and you count the number of different colors M&Ms, and the frequencies are shown to our table on the right. Test to see if the manufacturer has correctly advertised this percentages using a 5% significance level. So notice we got category 1, brown, category 2, yellow, 3, category 4, category 5, and category 6. So this means that there are 6 different categories here. So K is 6. For every category, we also have a claimed distribution. We know that for brown, there should be roughly 12%. So the PI, that'll be 0.12. For yellow, 0.15, 0.12, 0.23, 0.23, and 0.15. So these are the claim proportions here for each category. And you want to go ahead and do a hypothesis test. So let's go ahead and start this. Let's write the hypothesis. So number 1, let's get our hypothesis going. And essentially, you just want to try and mimic the verbiage used in the problem. But here we know we're talking about the color of M&Ms. Okay, so we're going to go ahead and say the color of M&Ms follow the claimed distribution. That's this one. The alternative is that the color does not. I guess I should be more precise and say peanut M&Ms, but that's okay. All right, so we got our hypothesis. Next step is we got to check the conditions. So the requirements. Now, the requirements only depend on the EI, right? We're going to assume that this is a random sample, independent, and so on. So we're asking, are the expected counts greater than 1 and no more than 20? Of the EI are small enough, in other words, less than 5. So you actually need to find the expected counts, always. So let's go ahead and find the expected counts. So here we're going to put expected. And remember that the formula for this is N times PI. So you need to know your sample size. Unfortunately, they didn't tell me the sample size. They just gave me the frequency. So frequency in group 1, frequency in group 2, group 3, 4, 5, and 6. But that's okay because we've seen this before in earlier chapters, and all we do is we're going to add up all of these numbers and get our sample size. I've already done it. It turns out there's 400 M&Ms. So this was a big bag of M&Ms. So from that 400, we can go ahead and multiply 400 with the corresponding proportion, claim proportion of 0.12. Okay, and we'll just do that for each one of these categories. And that'll give me the expected count. So unfortunately, you do need to do this by hand. But luckily, it's just multiplication. So it's not all that bad. If you do this by hand, you find that this is 48, this 60, 48 again, 92, 92, and 60. All right, so now that we can see the expected counts, we're going to ask, is each expected count greater than 1? Clearly, the answer is yes. Now, are no more than 20% of the expected counts small? In other words, smaller than 5? Clearly, the answer is yes again, because there are no expected count less than 5. So the conditions are met. We can go ahead and continue with the goodness of fit test. So let's go ahead and sketch our chi-square distribution with degrees of freedom equals k minus 1. So it's going to be 5. And remember that for chi-squared goodness of fit test, it's always a right tail test. So make sure that you only get the right tail. Alpha is 0.05, chi-squared sub alpha. And go ahead and find the critical value. So now we're at the point where we need StatCrunch. So hopefully you type in your data. So you want to type in the frequency and the expected counts. And then we're able to find our test statistics. So my test stat is going to be the chi-squared stat, as well as my p-value. All right, so go ahead and find these statistics. Go ahead and put pause, give it a shot. All right, so we're back. The critical value for this is 11.07. The chi-square statistic we find by having our data, so frequency M&Ms and expected count M&Ms in StatCrunch, and then going to stats, goodness of fit, chi-squared. We're going to select the observed for M&Ms. And notice that the observed is just the frequency that I actually got when I did this sample. The expected is here, expected M&Ms. And we are good to go. So we've got our summary here, as well as our test statistics. So that does not look good for us. So it'd be 6.9 and 0.61. So notice that our test statistic lands somewhere in here, maybe here. So obviously we're going to fail to reject the null hypothesis. So we're going to interpret this. We have, the interpretation is, we have insufficient evidence to claim that the color of M&Ms follow a distribution that's different than advertised. Than what the manufacturer advertised. All right, and that actually makes a lot of sense because the manufacturer is the one that has control over this, right? They're the ones that mix the colors. So whatever process they're employing, our sample tends to agree with their claim distribution, which makes sense, again, because they're producing this. Now, I do want to point out that whenever you reach a conclusion, always go back and just compare. Here's the claim observed frequency. Here's the claim that it should be 48. 66 versus 60. 38 versus 48. So that one maybe has quite a wide gap there. There's some There's a lot of disagreement with the red, but the rest of these have pretty good agreement. Check this out. 59 to 60, separated by 1. 96 by 92, that's 4. And then 88 to 92, separated by 4 again. So really, it looks like only the red seems to have quite a lot of disagreement. But overall, that one difference is not different enough to really have caused me to, question this distribution. It's just one mismatch here. Everything else seems to agree. All right, that's the end of our example. Thank you for joining me.